Hi there. I'm Andrew, and this is a short demo on the sudokuSolver app that I made. Towards the end of March, Concordia stopped having students attending class in person, and our JavaScript course cohort took 2 weeks off of the program in order to discuss and figure out what we are going to do. We ended up deciding to complete it remotely, obviously, and I took the first week of those 2 weeks to complete this. Um, so um, Here we have different tests that I've already put in. So this is a easy Sudoku problem. You can see you're given a lot of numbers and whatnot. If you click on help, um, I mean, you can click around and input numbers, obviously. I'll get to that later. If you click on help, what it does for each cell is it shows you a 3x3 grid of each possible number. I guess it should be mentioned that this presumes you kind of know how to do Sudoku, otherwise this will just be very confusing. But basically the idea behind Sudoku is that you need to put numbers 1 through 9 within each 3x3 grid, and within 9 3x3 grids, and you can't have a repeating individual number on any row, column, or 3x3 grid. So yeah, here you see these numbers, for example, and all the ones in red are ones that this cell cannot be. So we know this one can't be a 1 because there's a 1 here, and there's a 2 here, so this can't be a 2, and there's a 3 here, so this can't be a 3. But it could be a 6, an 8, or a 9. And so there's an algorithm that does that for each cell, pretty straightforward. And over here in the GUI, we see, do we have new information? It says yes, because the program just started. If we start doing tests and it doesn't find new information, then it will say that we don't. Is it solved? No, because we're missing numbers. And are there issues? That means, is there a conflict? No, there's no current conflict. If we were inputting numbers ourselves, we could easily make a conflict. Like if I just said go to play and I put in a 1 here, okay, we have a conflict. Anyhow, all right, so then test for naked singles. So I'm going to click this and then I'll go to 1. So here's 1. All right, this one highlights in blue. That's because for this cell, an 8 is the only possible option. So this ran through every unknown block, every unknown cell, and tested whether or not there was only one option available. I didn't choose the word naked singles. That is the what you call it, the name that's given in the community. I don't know. Anyhow, so now all of these ones can get added by clicking add new knowns. And we can keep doing that. And actually, I think if we just keep doing that, we can actually solve the very easy one because we're given so much information. Yeah. So now we've completed the puzzle. Reset it, and we'll go to a slightly harder test. All right, and now if we do that a few times, we should encounter a point where here, now, there's nothing new. All right, so now there's different kinds of tests. This is not just, single process elimination. That's the only possible option. This one tests columns. So it says in this column, is there a case where an individual number can only fit in one place? So I click this, okay, 4. So if I look down this column, all right, you see the 4 is red, this one's taken, the 4 is red here, the 4 is red, 4 is red, the 4 is red, the 4 is red. So this is the only cell where we could possibly have a 4 here. And the same is true with all these numbers, and you can add them. Test rows obviously does the same sort of thing, except by rows. And test by block also does the same thing, where you look at the 3x3 and it says, okay, this is the only place a 6 fits in this 3x3 block. And we added it. So we can save time and just click this button. This solve with simple logic will use all of these tests repeatedly until it finds an answer. So I click that, it just automatically solves it. And if I go to a hard test and I just click solve it, doesn't do it. So for this harder problem, testing with these tests actually won't find the solution. So then we start testing for naked pairs. It's kind of complicated, but often what happens in Sudoku is that you end up with 2 cells that are complementary that have a pairing of numbers. So like, let's say this is a 1, and this could be a 1 or a 4, and this could be a 1 or a 4. That means that all the numbers within those cells can't be 1s and 4s. Anyway, it's just another way of finding information. often it doesn't even, it's common that you won't actually find naked pairs that improve your amount of information. So the next thing I did was I said, okay, so we're going to start solving with brute force. There are like weird algorithms you could do, like X-wings and whatnot, but it's actually just easier to program brute force than this to start programming, um, catching uh, the circumstances for those more complicated um, uh, processes. Okay, so what this does is it says, okay, it looks at the first cell we don't know, and it looks at this one. It says, okay, we don't know. This could be a 7 though, and it says it'll say, okay, what if this cell was a 7? Can I solve it with simple logic? And what it'll do is it'll either give back one of three pieces of information. Either it can solve it, in which case your whole thing's done. It can't solve it, and can't solve it will break into two pieces, because I said there was three originally. Maybe it can't solve it because it can't get any new information. If that's the case, it'll just move on to the next number, and it'll sequentially go through all the numbers. All right. But the other circumstance is that it might cause conflict. There might be a contradiction. And if that's the case, then we know that that number is not true. So if I say here, what if this is a 7? And all of a sudden it finds, hey, later on when I'm trying to solve it, there's a contradiction. Well, then that one's not a 7, and it'll make that red. So if I here click test with brute force, see the 7 here turned red. So it did create a contradiction. And now if I brute force progress, well, one of the things it does, it tries to solve a simple logic. And obviously we're going to get this one here as an 8. So here, I'll just click that first, and poof, we can solve it right away. So then I started going into harder problems. I'll just jump to a really hard problem that I found online. And even with solving brute force, I couldn't get one piece of information. So even with all those algorithms, I could not get anything. So then I made a more complicated algorithm that basically did this at a depth, another level of depth. It said, okay, let's pretend this is a 1, and then let's start going through all the numbers and testing what ifs. So it's like a double layer of potentials, and it actually does work. So if I click this, it literally is running through like tons of numbers, but it eventually does solve it. Probably like a couple seconds now. I swear it's not crashed. There we go. All right. So yeah, so I did this in like about 7 days, and then I showed it to my father, who does a lot of Sudoku problems. And he was like, "It's like that's great, because you don't just have the test that you can put in. You could go around here and put in your own numbers, whatever. So like if you have a problem you've been working on, you can't solve it, you can go here and you can click, okay, set the initial values, help me, and you could say, okay, well, this isn't a 6, and you can get some like a bit of guidance, and you can do it in increments so that you don't necessarily get the full answer right away, which can be satisfying in its own way. So I showed him this, and he's like, okay, but I can't I can't play the game. And the reason for that was because I didn't originally have this ability to switch to play, where you can, after implementing the numbers, navigate and change numbers. I added this like on like the last day, like the 8th day I worked on it or whatever. And because of that, what I didn't do, and I probably should have done, was I should have had a history of the puzzle as you solved it, so you could go back in time. And I say that because after I implemented this and I showed it to my dad, and what he ended up saying to me was, okay, well, I was solving it on my own and I made a mistake, and I found that out much later, but I can't go back and erase it. And that's true, because the way I programmed it was that all of these numbers are saved in a use state. And once you lock a number in, it changes all these numbers to red, like to false. And I didn't make it so you go back in time with that. So basically, if there's a human error, you need to restart. Yeah. So what I should have done was I should have implemented like a history where you could go back a step, or forward if you've already gone back. Yeah. So this was my first React project. I did it after Started like 3 days after learning React. It was a lot of fun though. I was originally trying to do a Sudoku solver in, I think, C++, like 10 years ago or something. But I had a problem because well, a problem. Uh, it's not a visual program, and I was console logging the grid after every iteration of algorithms that I was putting in back then. And frankly, it was annoying because I was making the program to prompt you for, okay, what test do you want to do next every time, and then you have to type it, and you have to type it, and I don't know. It wasn't as satisfying as this GUI. Anyhow, so that's it. Take care.